welcome back to another section of my YouTube channel tutorial. In this video, I'm going to talk about isolated system, then closed system undergoing a cycle. When we talk about isolated system, an isolated system is a system which doesn't exchange neither heat, neither heat nor matter with its environment. So when you say a system is isolated, whatever is within the system is completely isolated from its environment. Now, when you say a closed system undergoing a cycle, we'll come back to that. But let's apply the first law of thermodynamics to an isolated system. So in an isolated system, we are having, since it doesn't exchange heat no matter, you get the total heat supplied as well as the work done to be equal to zero, right? So therefore, the total internal energy, the change in internal energy of an isolated system becomes zero from the non-flow energy equation, because the non-flow energy equation, it was delta U was equal to Q delta Q minus delta hot W. But in this case, since Q and W is 0, we have delta U to be equal to 0. That is, for every isolated system, take note, the change in internal energy remains 0. So there wouldn't be any change in internal energy. You get it? For an isolated system. Let's come to closed system undergoing a cycle. For a closed system undergoing a cycle, we are going to have our changing. So I'm talking about closed system. We did the closed system in our previous video. So the closed system undergoing a cycle has its delta U to be equal to 0, and hence the first law. So what I mean is, if you have a closed system which is undergoing a cycle, the change in internal energy becomes 0. For that reason, from the first law equation, our Q net minus our W net becomes what? 0. Hence, the work done as well as the heat supplied becomes equal. So Q net becomes equal to the what? W net. I have an example here which we solve for you to understand this concept well. So during a complete cycle of operations, a system is subjected to the following heat transfers: 800 kilojoules supplied and 550 kilojoules rejected. At 2 points, work is done by the system to the extent of 96 kilo at the extent of 96 kilonewton meter. That is work done. So kilonewton meter and 20 kilonewton meter. At the third point, there is a further work transfer. Determine its amount and state whether it is work done by or on the system. Take note, the work done by or on the system. So let's see how we are going to solve this problem here. So our solution for this, our Q net. So we want to know whether work is done on the system or work is done by the system. So we want to find our W, that is work done. So now let's see. Our Q net is equal to our Q in then plus Q out. That is energy supplied, heat supplied, as well as the heat ejected. That will give us our total Q net. Now, what is our total Q net here? So we had our energy in to be 800 and it was positive. It was supplied in the question. So it said 800 kilojoules supplied and 550 rejected. So minus 550, and that is going to give us positive 250 kilojoules. So the Q net, that is the total heat supplied or the total heat contained in the system is positive 250 kilojoules. Now, let's find the work done, the net of the work done. So, we said at 2 points, the work done, the, at 2 points, work is done by the system. That means it's a positive work done. It said to the extent of 96 kilonewton meter and 20 kilonewton meter. At a third point, there is a further network transfer. So right now we have a third point as well as the first 2 points. So our total work done is going to be the 96 because it's work done by plus our 20, then plus the third work done which was not given. And that is going to give us 116 plus W kilojoules. Now we need our work done. That is what the question is demanding. So from the first law equation for a closed system undergoing a cycle, we learned that Q net minus W net is equal to 0. For that reason, our Q net, which is positive 250, will be equal to our W net, which is 116 plus W, right? So our work transfer W will be equal to 250 minus 116, and that is going to give us positive 134 kilojoules. From the value we've got, we can clearly see that work is done by the system. And this brings us to the end of this video. Thank you for watching. Kindly subscribe and like.